So, hey everybody. First of all, thanks for staying up this long. I know it's a beautiful sunny day outside, but you guys are staying, so you're the strongest ones. I'm here today to talk about how we as an industry are evolving in terms of trustlessness, how we are actually solving some of the problems related to trustlessness, and how in the meantime, we're also introducing another set of challenges. So, um, I might even walk you down the memory lane in terms of how we all evolved since very early days. But yeah, let's start from the very basics. So if we can go to the next slide. Um, I'm pretty sure that I'm not the only one in this room who has ever had a call from a bank or whenever you're trying to deposit money into a centralized exchange. And this just goes to show that every system that is built on any sort of trust has a failure mode. It has an attack vector that anybody can exploit for you to face certain consequences. So talking about those centralized exchanges, I think we're no shortage of cases where trusting them too much caused severe tragedy in terms of both financial and reputational was the word I'm looking for, a reputational harm done for the whole industry. And the whole point of all this is that middlemen, whenever they exist between two parties, they will find a way to eventually cause and extract value out of the two people or entities transacting, be it in the form of fees, delays, censorship, or whatever else that may be. And then if we go to the next slide, here's a high-level view of how we all evolved as a space, because essentially Web3 is there to eliminate that trust completely. And it all started with Bitcoin, so that's a very bird's eye view on how this industry has evolved in that sense. And again, I'm going to talk about how we started with Bitcoin and then how things evolved since. So starting with Bitcoin, next slide, please. We started that in 2019, and obviously we know why it was created, and probably it's because of Bitcoin that we're all in this room right now. It enabled us with a system where two people can transact with each other without any middleman, and that was the game changer ever since, right? You had no central bank that can inflate your currency. You have nobody to stop you from sending somebody money, and it basically enabled this statement saying don't trust and verify. And that all was great and good. However, there was one big limitation. Bitcoin could not do much more than that at the time, right? You could just send money to the other party, transact, but that was basically it. And good for us is that Ethereum came along. Please go ahead to the next slide. And what Bitcoin did to money, Ethereum did for agreements, which we call smart contracts, right? They operate under the law of code. They're always deterministic. They have no emotion. They execute as intended the moment execution is intended. And obviously, both Bitcoin and Ethereum are the most decentralized and trustless networks available right now. And the core thesis of Ethereum has been really solidified, and the value of it was proven back in 2020. If we can go one more slide. Obviously, the beautiful DeFi summer. By the way, who in the audience were there for 2020 DeFi summer? Yeah, I see quite a lot of people. Great days, right? You had all sorts of different DeFi primitives launching, decentralized exchanges, lending, stablecoins, which are to this day actually solving real-life problems in certain countries, and obviously the ever profitable yield opportunities where you would be able to earn 100% plus API just by providing liquidity, right? It was massive. We went from, I think, 1 billion TVL to 100 billion TVL in less than 2 years. The growth of it was insane to witness. And that's how DeFi proved an entire financial system can actually run simply on code. But that demand, obviously, as we know, caused certain problems in the space. And up until this point, it was kind of plain sailing, right? We have Bitcoin being efficient for what it does best. We had Ethereum, the most trustless and decentralized network. But then this most decentralized network faced some issues. And we can go to the next slide. It had a big scalability problem. I think a lot of us has paid more than $200 just to move $50 worth of assets, or if you had to actually transact on Ethereum under the demand times, under the times of huge volatility or just massive congestion on the network, you would wait a long time, really long time, days to even weeks for your transaction to get processed. And yeah, that was not fun at all. And this was where the scalability and trustlessness solving came under Jeopardy, right? So I just don't think it was logical, and obviously many other projects, as we'll soon find out, they all thought that spending the equivalent in price of a flight, let's say from London to Paris, on a single transaction, well, maybe not on business class, but using a low-cost carrier is normal, right? So as a result, long story short, we had a lot of, next slide, please, layer 2s launching. And long story short, you had all different sorts of layer 2s, from optimistic to ZK, different stacks, different architectures, all trying to solve the same problem at the same time. And in the end of the day, they did solve the scalability problem of Ethereum. But then what about trustlessness? I'm pretty sure it's safe to say that not all layer 2s at the time were fully trustless. And if my research serves me right, only back in 2024, we had our first layer 2s really trying to decentralize their stack, decentralizing their sequencers. And yeah, right now we seem to have a decent amount of attention on layer 2 side to really make everything trustless. So you can see the pattern now. We had a scalability issue in Ethereum, lots of layer 2s respond, but then another problem obviously appeared because we started to create, next slide please. We started to remind, the Web3 started to become the internet of 90s, fragmented, inefficient, and just unable to communicate to each other. Basically, let's take an email, for example. If you're using Gmail and you're trying to send an email to somebody who's using Outlook, in this example, you would have a custodian who's actually would be responsible for delivering that email from you to your friend, let's say. And if that custodian is actually busy and is actually saying that, hey, I'm too busy right now, please pay me more money so I can deliver that email, it's obviously not optimal user experience. And that's what actually happened when there are a lot of layer 2s, when there were lots of layer 2s created. It was impossible for assets to freely move cross-chain. I'm not even talking about trustlessness. So we broke the cross-chain trust by introducing these layer 2s. How do we solve this? Obviously, to solve now this problem, you had specific protocols launching, which at the very early stages were called bridges. Let's go to the next slide. And this is basically showcasing you the evolution of bridges. You, first of all, had super simple custodial bridges where basically this one single private key was handling everything. If that key was compromised, it was game over, right? Then you evolved into multi-sig bridges, which then evolved into general message passing protocols, which are still being used to this day. And probably right now we're evolving towards something else. So it just goes to show you how one problem, again, created another. And each problem then requires a whole lot of resources and funds to come up with a huge number of different protocols trying to solve the same problem. And obviously, I'm not even talking about the exploits that we had in the bridging world, right? You had the Ronin hack, you had the wormhole hack. So much money has been lost, at these exploits. So yeah, so the question is, how are we going to now completely align all these different chains? And is there an on-chain native way for different chains to talk to each other, perhaps even based on on-chain events? The question is, what's building this? And if we go to the next slide, I'm going to try and touch on how the Reactive network that I'm part of is trying to solve this problem in the industry. I put a headline saying that Reactive is an on-chain computation triggered by external state, which in simplified words, let's go to the next slide, is the on-chain if this and that system based on the concept of reactive contracts. Reactive contracts are very similar to standard Solidity contracts with one big difference. They actually execute not when they're not directly called by the end user, but when there's some event happening on the blockchain, on actually the origin blockchain. So what happens next is that the reactive contract will get executed, triggered by that event, and execute an additional modular solidity-based logic, just like you normally would on a typical EVM contract. And once that execution is complete, you can then decide what happens next. You can even call a different contract on-chain B, or just sit there and let the reactive contract accumulate state until some threshold is met. So it's all based on your typical solidity that developers are familiar with. And the beautiful part of this is that it's all on-chain. No logic ever moves out of chain to any bot or keeper or anything that's being used today to usually automate those functions. So again, next slide, please. Really quickly, let's summarize. There's any event happening on, let's say, Ethereum. You have a reactive contract that is interested in this event and that says, okay, once that event gets emitted, I want to execute this. You actually perform that logic on the reactive network and then take action on the destination chain, which can actually be the same chain as an origin chain. Now you might be thinking, what can you build with this? Let's go to the next slide. Honestly, there's a lot of use cases. Recently, we hosted a hackathon alongside the Uniswap unit chain, and obviously they're focusing a lot on V4 hooks. And that hackathon actually was a huge success for us in the fact that there were a lot of use cases found and synergies found between hook contracts and reactive contracts. And the result of this is that people could really see how customizable can Solidity actually be when the right technology is being used. But going back to the use cases, we can think about things like automated leveraging, liquidation protection, all sorts of on-chain stop orders, limit orders, TVAP orders, keeper-free lending liquidations, automated LP range rebalancing, anything you can think of that is based on on-chain events. And yeah, basically, if you are interested in learning more, there's a link below. There's an ecosystem page on our website which shows real-life examples because this technology is fully on mainnet, it's live here and ready to be used. So yeah, there are a lot of use cases, honestly, and it's really hard to put them all in one slide, but just basically think about anything events related that you can build on top of and execute next. So this is all meant to prove the fact that transparency, it's not really a feature. Like, we're all here in this space trying to decentralize things and trying to remove all the middlemen. And in the world of automation, this is Reactive's take on the matter. So to summarize everything, reactive contracts prove that every action has been recorded on a chain, since you can actually use the origin chain block explorer to watch which transaction executed a reactive transaction, and then furthermore you can prove that the execution of reactive contract did what it was intended to do on the destination chain explorer. Literally, no data has ever leaves the chain. Deterministic, so just like any Solidity contract, will actually be predictable. The same goes for reactive contracts. It's all the same, except for the fact that reactive contracts subscribe to some events and not act whenever directly called. Permissionless, it's open infrastructure, so developers can go ahead, take a look at our docs and start building right now. And furthermore, you can be very modular with your logic and come up with all sorts of workflows based on multiple manual steps that can talk to, that can cooperate each other across chains, even not in a single step environment, but also multi-step environment. So if we go to the next slide. As we talked about in the very beginning, the pattern is always the same, right? We first of all find the trusted intermediary. In our case, we found that there was no Web3 native solution to automate stuff on chain. We're trying to replace that by giving developers the opportunity, because everybody keeps claiming that they care about decentralization, they care about trustlessness. So if you really do care about trustlessness, if you have a multi-chain app and you want to automate something on chain, Reactive should be the natural choice for that. And yeah, that way we are hoping to add the trustless element to the space so that no logic ever gets emitted on the blockchain, and the user of an application, if he or she gets liquidated, would have a clear proof when the transaction happened that triggered the liquidation and the proof of the liquidation itself. So there's really nobody to blame. So what Ethereum did for logic, what Bitcoin did for payments, we're really attempting to bring to on-chain world using reactive network. And it's all there for you to be explored. If you go to the next slide, we have a different program coming. It's actually live right now. We even have signed like a very latest and fresh project. And I met their CEO today in this conference. I'm not sure if he's there, probably not anymore, but I'm just trying to say that it's not a gimmick dev fund. You can actually apply and get incentives for utilizing the technology. For anybody interested in the technical part, here's a link at the docs. And yeah, for all the projects that are already live, maybe for use case ideas or just to see what's possible, you can check out the ecosystem page. So I'd like to end by saying that Trustless is, and it can be a verb. Like initially I thought about the title of this talk and I said, okay, maybe we can talk about the march to trustlessness. Maybe I should name it the march to trustlessness, but it's not March anymore. It's actually April 1st, to be honest. So I went with making trustless a verb. So let's make trustless, let's make automation trustless. Thank you guys. And if you guys want to get in touch with me, catch me post stage or let's talk on Telegram. Thank you.